Liquid Penetrant Testing. A. Module 10. Introduction to Non-Destructive Examination. So, introduction to liquid penetrant testing. So, penetrant testing is where we use a liquid to detect surface breaking discontinuities, cracks, pits, porosity, inclusions, in non-porous materials. And by non-porous materials, the material can't be sponge-like. If it is, it's not going to work. This method, we're going to use dye, and it's in a fluid, which is going to penetrate any surface discontinuities and flaws, and it's going to go in there through capillary action. Then we're going to wipe off all the penetrant off the surface, and this is going to allow, and then we're going to put an enhancer on it, and then this is going to increase the visibility of the discontinuity by giving us a visual contrast between the discontinuity and the surrounding surface. So liquid penetrant testing, PT, as I said, it reveals open discontinuities by bleeding out of a liquid penetrant medium against a contrasting background developer. And it's basically, we're going to have, I don't know, food coloring bleeding out into chalk. And this boils down to, the penetrating liquid is going to wet a surface, and then it's going to penetrate into an opening, and then it's going to be drawn into it. So liquid penetrant inspection is used to inspect metals for surface defects similar to those revealed by mag particle testing. Unlike mag particle testing, which can reveal subsurface defects slightly, the PT inspection reveals only those surface defects that are open to the surface. Both ferrous and non-ferrous metals can be inspected using the PT inspection. So there's a lot of similarities between visual mag particle testing, MT, and dye penetrant PT. They're all visual processes, but there's a couple of different methods. One uses magnetism, others use a dye to penetrate it, but they're kind of lumped in that same family. They might not live on the same street, but they live in the same city, if that makes any sense. The background of liquid penetrant inspection is, it goes back to the railroads. 150 years ago, the maintenance shops in railroads back in the late 1800s. So they'd have parts that they were going to inspect, and they'd put them into used machine oil, which was very black, used burnt, oil that you're getting out of a deep fat fryer kind of thing, where it's just burnt to a crisp and it's not clean and clear. Well, then they'd throw these parts into the oil, and then the parts would come out of the oil, and then the excess oil would be wiped off with rags and wadding, and to get all the surface oil off of these parts to be inspected. Well, this became known as the oil and whiting method. So the part surfaces would then be coated with powdered chalk or a mixture of chalk suspended in alcohol. They'd put that on there. Well, that would draw the oil trapped in the cracks or the flaws would bleed out onto the white chalk, and it'd leave a noticeable stain in the white chalk coating. This became known as the oil and whiting method. This is the background of it. You can see how this would have evolved and how useful it would be in finding defects, flaws, and whatnot in railroad situations. So this is where it comes from. This is where it was more or less invented, and then others refined it. So why do we want to use liquid penetrant inspection? Well, it's inexpensive, it's reliable, as far as a non-destructive method goes, and it's great for just finding and detecting discontinuities that are open to the surface. And we can use it on things like aluminum or other materials that might not be magnetic. The key is it's got to be non-porous, and the materials can't be harmed by penetrant materials. So that's another one. but in a lot of situations, this is a really good method to use. So the basic steps of this process are, one, we're going to clean the test surface. So we'll get out some kind of cleaner, some kind of acetone, industrial cleaner, clean the surface. Then we're going to apply the penetrant. In the ones we're talking about right now, we're just going to talk about spraying it on there. But there, we can put it on with a brush. We could dip it in a big pot of, a big container of, penetrant, whatever. And then we spray it on. We're going to wait for the prescribed dwell time. We're going to let it sit and let that penetrant soak into those defects or discontinuities. Then we're going to come along and we're going to use, paper towels or rags or whatever to remove the excess penetrant off the surface. This is just going to leave penetrant in the cracks. Then we're going to apply our our developer. Like we said in the previous couple slides, we're going to throw some chalk on there. That's more or less what we're doing. And that chalk or that developer is going to pull out the penetrant, and then it's going to give us an indication. So then we're going to examine the surface for indications, and we're going to record the results. And then we're going to clean to remove any residue that might be left on the surface of the part. So cleaning, a lot of times, and I'm just using one of the methods here where we use spray cans. You can get spray cans for dye penetrant. They're little kits that come with it. So you want to, make sure and clean the part before you perform dye penetrant testing. So we're going to clean it and then remove residues, soils, rust, whatever from the surface. Cleaning is super critical in this instance because if we don't get it cleaned, we could get false positives, or it could damage our results, give us bad results. So we really need to clean the part. That's super important. Like I said, contaminants, soils, moisture, either inside or outside the flaw on the surface, can really reduce the effectiveness of this inspection type. So we really got to clean. Clean is good. So then we're going to come back with another spray can and we're going to apply the penetrant. Once this is clean and dry, we're going to throw a penetrating liquid on it and this onto our clean part that's going to be inspected. Then we're going to allow the penetrant to remain on the part surface for a dwell time, a period of time, to allow it to enter and fill any surface breaking openings or discontinuities. So with the dwell time, all we're doing is in your instruction kit or in your process that you're supposed to be following, the penetrant is going to be allowed to remain on the part surface for a period of time, and that's going to allow it to enter and fill any surface breaking openings or discontinuities that are out there. So it's just going to soak in there. Well, then we're going to come back and we're going to remove the excess penetrant. That's what we're going to do next. So after we've hit our dwell time on our stopwatch, the penetrant's going to be removed from the part surface. All right, so you want to make sure that you don't get too overzealous with your cleaning. You just want to remove that excess penetrant. You don't want to scrub out what's inside the cracks or the discontinuities. So you got to be careful here. And then we're going to apply the developer, another spray can. This is basically chalk in a can, right? It's going to spray on there white. Kind of like the lines on a football field or a soccer field. It's just chalk in a can. The developer is going to aid in drawing any trapped penetrant from the discontinuities. It's going to pull it out. And it's also going to give us a good contrast, because maybe if your dye is red and this chalk is white, we'll be able to see the discontinuities because there's that contrast between the two colors we're using. So then once we've done that, our next step is going to be visual examination. So then we're going to get it under the right lighting conditions, and then we're going to make sure that we identify any relevant indications. And that's pretty much what we got to do. And we're just going to do that. And then when we're all done and we've dispositioned it, we're going to clean the part afterwards. We're going to post clean the part, which is really important. We don't want to leave any residues or any crud on the part that's going to maybe have some kind of long-term corrosive effect on our parts. You know, like I said, like it says here, you know, this is super important because these residues can have adverse effects on, you know, whatever we're going to do to it next, or maybe the end service that we're going to use this part for. So that's something that we need to be cognizant of. Once again, post cleaning of the part. You know, residual inspection materials might combine with other materials in service to produce corrosion products. So maybe you have, you know, you could have a situation where you leave that residue on there, and then there's other materials that are going to be put on after your part's been inspection, and then it could lead to corrosion type situations. And we really want to avoid those types of situations. So once again, post cleaning of the part is super important. You know, a lot of times, you know, simple water rinsing, machine water, vapor degreasing, you know, solvent soaking or ultrasonic cleaning, depending on what you're got going on. But these can all be employed depending on, you know, what type of method you're using for dye penetrant testing.
Here's an LP inspection station. This would be, you'd set something like this up if you were going to be doing a lot of parts over and over and over, you know, some kind of production situation. I worked in a foundry where they had something similar to this, but it was much larger, but they had black lights and, you know, a draining station, and it's for doing parts the size of a Volkswagen. They didn't, you know, break out 512 cans of dye penetrant and spray it on the part and then hit it with the, you know, the developer. They had stations set up, and this is one of many possible, you know, configurations for LP inspection stations. You know, a cabinet situation like this where you've got some sinks and you know, some cabinets, and then you've got the black light inspection station like a booth where you can close it off and it's absolutely dark in there, and you can hit the part with a black light and see if any indication. Penetrant inspectors should be qualified and certified in accordance with SNT TC1A or a similar document. To provide permanent records, photographs of the specimen should be taken prior to post-cleaning. Post-cleaning is only required for those specimens that are found free of defects. Defects are described by engineering documents or in contract codes and specifications. Post-inspection cleaning is necessary since the penetrant and developer residue tend to attract moisture, which can cause corrosion or can interfere with subsequent processing or usage. The cleaning methods for post-inspection cleaning are generally the same as those recommended for the pre-cleaning process. So this is just telling us, hey, the penetrant inspectors, they need to be qualified. You need to have paperwork on them. SNT TC1A is a great document to provide guidance in how to qualify non-destructive testing personnel. Then you want to make sure and provide permanent records that you did an inspection. And in this day and age, it's photographs generally from a cell phone or a small digital camera. You stash those on a hard drive of a computer or a server somewhere, and then you clean the thing, you disposition the part, and then like I said, you did the post inspection cleaning. And then you're on about your business to the next part.
So the advantage of liquid penetrant testing is it's usually very cheap and often is the cheapest method other than visual testing. It's usually quick, even for large parts. You know, you can get it done pretty quickly. Can be portable. We can get a stack of basically spray paint cans and go to the site and do what we need to do. Reasonably easy to interpret. You don't have to be a non-destructive testing guru to interpret the results. Yep, that's a crack, that's porosity. You can, with a little bit of time, you can end up with pretty reasonable skill set for interpretation of results. So the disadvantages of liquid penetrant, you know, we're only going to be able to detect defects that are open to the surface, flaws, defects, and whatnot open to the surface. Anything subsurface, we're not going to get to. We're going to have to use X-ray or ultrasound to get to those. You know, and there's no automatic or permanent records. Granted, nowadays we have cell phones and we can just take a picture and include those pictures, those photographs that we've taken into a non-destructive testing report. You know, the technology's come a long ways to allow us to do this. You know, it's not like X-ray where we're going to have a hard copy of the X-ray that was shot. We're going to have to take some pictures, but in this day and age, it's much easier than it was 30 years ago. We'd have had to use a Polaroid or something. Often requires a pre-cleaning step. You know, a lot of times you're going to have to clean it before you do the inspection, so that could be a hindrance to some. So if we really want to get the maximum out of this, a lot of times they use fluorescence, use fluorescent lights, and have a special type of penetrant testing dye to get or to penetrate in there that is going to, you know, fluoresce when a fluorescent light is put on it. You know, and it's not good for rough or porous surfaces. If it's a porous surface with a lot of holes in it, it's not going to work very well. Some of these penetrants can attack, you know, rubbers, plastics, you know, and they should have a low sulfur or low chlorine content when we're using them with stainless steels, nickels, and titanium materials.